Okay, so for 1.2, we're going to deal with the second part of our transformations, which are stretches and compressions, or stretches and shrinks. So today, I know yesterday we skipped horizontal stretch and compression, but today we're going to go back to that. So that's why I put this first page on it again, on the notes again. So today we're going to look at horizontal stretch and shrink, is what our book calls it. So a horizontal stretch or shrink is when our number in our x inside the parentheses gets multiplied. However, for horizontal stretch and shrink, we're multiplying it by the reciprocal of the number. So if we see for our example here, we have x inside our absolute value that gets multiplied by 1/5. And this is a horizontal stretch by 5. So we just take the reciprocal of what's being multiplied. For the second example, we see y is equal to the absolute value of 3 times x. So x is being multiplied by 3. So this would be a horizontal compression by 1/3. So we just take the reciprocal of 3. So going back to this picture where it has all of our examples on what type of transformation is happening, if a number is being multiplied to x inside our parentheses, we have a horizontal stretch or shrink. And it's always going to be the opposite of what you think. So if it was a number like 4 that gets multiplied to x on the inside of our parentheses, this would be a shrink of 1/4. So anything that happens inside the parentheses, it's always the opposite of what you think. Just like when we subtract a number inside, we move right. It's the opposite of what you would think inside the parentheses. So that is for horizontal stretch or shrink. All right, so now let's look at our examples. So let g of x be the indicated transformation for f of x. Write the rule for g of x. So for a, we have f of x is equal to 2x minus 1. And we need to apply a horizontal compression by a factor of 1/3. So horizontal means that it's going to happen inside our parentheses. And since it's a factor of 1/3 for horizontal, we need to change it to the reciprocal. So we're going to multiply x by 3. So we change our fraction to a whole number. So we're going to take this 3x and plug it in to our x in our equation. So we have 2 times 3x minus 1. And we could leave it like this, or we could multiply the 2 times 3x. So it would be 6x minus 1. For b, we have a vertical compression by a factor of 1/4. So vertical compression, nothing changes, we just multiply the outside of our parentheses by 1/4. So here we have g of x is equal to 3 times 1/4 times x plus 2. And then we can just multiply our 3 times 1/4 together, which would be 3/4. Any questions so far? All right, first.
Are you just basically multiplying?
Yes, so for stretches and shrinks, or stretches and compressions, we always multiply.
Okay.
All right, so for C, we have 1/3 x minus 2, and then we're applying a vertical stretch by a factor of 3. So what do we need to do to x to apply this vertical stretch by a factor of 3?
Multiply by 3.
The inside or outside?
The inside?
Remember, vertical happens outside, horizontal's inside.
Oh, okay.
So, but for this one, when we do it, it really doesn't matter. But if it was like an absolute value one, or if it was a quadratic with parentheses, then it would really matter. It would change the whole equation. But here we are multiplying the outside by 3. So we have 1/3 times 3 times x minus 2. So we just multiply.
Yeah. So for vertical, we don't do the reciprocal.
Correct.
For horizontal, we do.
Right. So horizontal happens inside, and inside it's always the opposite.
Oh, okay. Thank you.
So now we can simplify this. What is 1/3 times 3?
Nine, right?
1/3 times 3.
Oh, 1.
1. So this would be 1. So we can just put x minus 2. All right, and then now for D, we have f of x is equal to negative 2x plus 5 and a horizontal stretch by a factor of 4/3. So here it's horizontal. So what are we multiplying by our x?
3/4.
3/4. Awesome. And since it's horizontal, it happens inside the parentheses. So we have negative 2 times 3/4 x plus 5. And now we can simplify this by multiplying our negative 2 times 3/4. So what do we get when we multiply negative 2 times 3/4?
Negative 3/2.
Negative 3/2. Awesome. So negative 3/2x plus 5. Any questions on horizontal or vertical stretches and shrinks? All right, so the second part here, we have combining transformation. So this takes what we did yesterday and today and puts it together. So we're gonna have more than one transformation that happens here. So example 4, let g of x be the indicated transformation of f of x, write the rule for g of x. So we have f of x is equal to x, we need to move it down 2 units, followed by a vertical stretch by a factor of 5. So what happens when we go down 2 units?
Minus 2.
We subtract 2 at the end, so outside of our parentheses. And then what do we do for a vertical stretch by a factor of 5?
You need to put 5. I actually don't.
Multiply it by 5 inside the parentheses. I mean outside.
Outside, perfect. So we multiply by 5 outside the parentheses. So now we're going to put those together for our x. So we have 5 times x minus 2. So our g of x is equal to 5x minus 2. For this one, it's important that you guys know that down 2 is outside the parentheses, because if it was inside the parentheses, it would change the whole problem.
For example, would it be wrong if like the answer would be g of x equals 5 parentheses x minus 2?
Yeah, so if you had parentheses here,
No, I mean just x, my bad. Just x. Counted as wrong?
no, it wouldn't be wrong, but you just don't need them. It's not needed.
Alright. Thank you.
Any other questions from this one? All right, next page. Let's take a look at B. Again, we have f of x is equal to x, and we have a vertical compression by a factor of 1/2, followed by a horizontal shift of 8 units left. So what do we do for a vertical compression by a factor of 1/2?
But 1/2 out of the parentheses? Or are they on the outside?
We multiply 1/2 on the outside. And then what would we do for a horizontal shift 8 units left?
Plus 8 units inside the parentheses.
Awesome. So we have 8 plus x inside the parentheses. So now we take our 8 plus x plus 8, and we multiply that by 1/2. We got to make sure that our plus 8 stays on the inside and our 1/2 stays on the outside. So g of x is equal to 1/2 times x plus 8. All right, for C, we have a vertical compression by a factor of 2/3, followed by a vertical shift 6 units down. So what happens with a vertical compression by a factor of 2/3? We multiply by what?
2/3.
2/3 on the inside or outside?
Outside.
Outside. And then what about a vertical shift 6 units down?
Minus 6 units on the outside.
On the outside. So we have x minus 6. So now we just plug everything in for our g of x. So we have 2/3 times x minus 6, So here it's important that we don't have any parentheses because everything happens on the outside. Any questions? All right, let's look at D. We have a horizontal shift 4 units, shift right 4 units, and a horizontal stretch by a factor of 3 halves. So what do we need to do for a horizontal shift right 4 units?
Add it to the outside.
So remember, right and left happens inside. So what do we?
Subtract it from the outside or the inside?
Perfect. We subtract it from the inside. So we have x minus 4 on the inside. And then next we have a horizontal stretch by a factor of 3 halves. So what are we going to do to our x?
Subtract it on the inside.
A horizontal stretch is happening.
Oh,
Multiply it by 2/3.
Multiply it by 2/3. Remember, we have to take the reciprocal. Awesome. So we're multiplying it by 2/3, and since it's horizontal, it happens on the inside. So everything here is happening inside our parentheses. So we have 2/3 times x minus 4.
Ms. Carter, why did the number change?
The number for the horizontal
The
stretch?
fraction? Yeah.
Because when it's horizontal, we have to do the reciprocal.
Oh, okay. Okay.
So our g of x is equal to 2/3 x minus 4.